Hey everyone, good afternoon and good morning to those of you in the United States. Perhaps good evening to others of you as well. Thanks for joining our live stream today. Today's online lecture is presented by the National Capillary of Skeptics, NCAS, also known as NCAS. I'm Scott Snell, NCAS president, speaking to you from my home in Greenbelt, Maryland, just outside Washington, D.C. NCAS serves the DC, Maryland, and Virginia area and online as advocates for science and reason. We promote the scientific method, rational inquiry, and education. Find out more about us at ncas.org and also have a look at our collection of past NCAS lectures on our YouTube site. You'll find interesting lectures on topics such as Scientology, how to read a medical study, and how to scientifically investigate ghost stories, among other things. NCAS has been hosting our monthly public lectures since our founding in 1987. Usually we host lectures in Maryland, Northern Virginia, and events in DC, but for the time being, we'll continue our lecture series online, typically on the second Saturday of each month. Here's a news item for our viewers along the eastern seaboard of the United States. Sunday evening at 7:27 p.m. Eastern Time is the next launch to the International Space Station. It's a SpaceX launch from Kennedy Space Center in Florida, carrying a crew of 4 astronauts to the ISS. If you don't have clouds blocking your view of the eastern horizon, you can see the rocket pass by. For example, those of us in the Baltimore and Washington area go outside after the launch, watch the eastern sky. And about 7 minutes after launch, you'll see the Falcon 9 rocket moving from right to left, several degrees above the eastern horizon. The rocket engine will shut down at 8 minutes and 50 seconds after launch. So if the object you've sighted suddenly vanishes at that moment, you'll know you saw the rocket and not an airplane or a UFO. Anyway, hopefully our weather will cooperate, and launch is scheduled, as I said, for 7:27 p.m. tomorrow night. Okay, before I introduce our speaker, here's a quick run through on how we'll handle questions and answers. To the right of your video display, you'll see a chat window. Go ahead and post your questions there. You have to sign into a Google account in order to post. And if you would, include the name of your city or town and post your questions anytime. Our speaker will answer them after she finishes her presentation. All right, it's my pleasure to introduce Caitlin Ahrens, a planetary scientist at NASA's Goddard Space Flight Center, specializing in lunar ices and impact craters. She also produces the Scratching the Surface weekly segment and forthcoming podcast about planetary science news for KUAF-FM, the NPR station in Fayetteville, Arkansas. Named one of the 2018 10 Outstanding Young Americans by the United States Junior Chamber, Dr. Ahrens volunteers as a NASA Solar System Ambassador, communicating the science and excitement of NASA's space exploration missions and discoveries with the people in their communities. Joining us from her home in Olney, Maryland, ladies and gentlemen, Dr. Caitlin Ahrens.
Thank you so much for that amazing introduction, Scott. I'm so happy to be here today to talk about science fiction and cinema and pretty much how 1950s, 60s, and 70s cinema pretty much viewed our solar system through a camera lens. So I cannot wait to show you what all I have found. Now, granted, there are so many movies that can be portrayed as far as sci-fi goes. So for this presentation, we're going to pretty much stick with our solar system. Space travel is very minimum with this talk, though, but I will be happy to answer any questions that you may have in that regard. So let's start this adventure, shall we? So every trailer in the 1950s, 60s, and 70s pretty much opened up with the big shebang, usually an adventure that you've never seen before kind of deal, a film that no one has ever seen. It's out of this world. You got to go with the buzzwords, right? But caution, there will be spoiler alerts. Many of these movies you probably have not seen or even heard about. But I do recommend most, if not all, of these films that I'll be showing you today, though. So, but word of caution, there is a spoiler alert. So just a little history lesson, though. So what was considered the first piece of science fiction? And what do we actually think about science fiction in general? So the most early form of fiction at the time was probably around the 4th or 5th century BCE in Hindu poetry and even Greek plays citing air travel. But then what about otherworld traveling, communication across the stars, even stellar warfare? That was eventually evolved in the 2nd century, usually with the Syrian Greek writer Lucian. This particular piece of work called True History had outer space travel, it had alien encounters, it had interplanetary warfare, moon people versus the people of the sun. And for that, we take for granted nowadays that that just sounds like every sci-fi book that we've probably ever read in our lifetime so far. But considering at the time this is 2nd century, this was very original for its time being. And it had space spiders as well. If you can find an English translation of this work, I highly recommend it. There are space spiders, which is terrifying enough. I'm afraid of Earth spiders as it is. I don't need space spiders in my closet. Another little fun history going on here, though. So the bamboo cutter is 10th century Japanese. You have a moon princess sent to Earth during a celestial war, and then later sent back to the moon. I also highly recommend 1001 Nights. This is also 10th century. It's a story collection, rather. My favorite is Ebony Horse. It's mechanical horses that fly to the sun. There's also The City of Brass, which you have almost robotic android-like horsemen. But keep in mind, though, this is still 10th century, though. So there was no notion of electricity at this time. Then you start to get into the 17th and 18th centuries. This is where you get into the Age of Reason. So a huge boom of certain works, usually with traveling, specifically Gulliver's Travels in 1726 by Jonathan Swift. Kepler also wrote a couple short stories, one of them being Somnium in 1634, which had voyages to the moon. Voltaire also had Micro Maga, which had a very advanced worlds, more advanced than Earth. And then later on in the later 1860s, all the way to 1890s, you have the Verne and Wells scenarios going on. So definitely flying to the moon, you have more rocket ships going on, or you have visitors coming to Earth and pretty much destroying the world. So now we're going to get into the fun part, the cinema part, how to interpret such wild imaginations onto the silver screen. So 1900s to about 1930s, you have the silent era. So this is where you have more of the experimental, everything is new for the silver screen. So not necessarily diving into a sci-fi era, though. There are 3 particular great works. A Trip to Mars is a German-Dutch film. Woman in the Moon is also pretty good as well. But we all know this particular picture, the rocket ship pretty much going bullseye right into the moon, and the moon, you know, poor moon guy just kind of hurts a little. But 1930s really shows its true colors. You have the serial era, and one of the greatest series of that era is the Flash Gordon series. So he had kind of a long-running adventure with Flash Gordon's Trip to Mars. So not only is this really getting into the hero versus villain multiple characters, a long series, usually 15 or more chapters, although at the time, what we consider episodes. You also have more fun with how rockets would look at this time as well. So real quick with Flash Gordon's trip to Mars, what you see here on the screen, though, is pretty much their civilization on Mars. So obviously that's a no, not yet anyways. You know, maybe far flung into the future, we may build up such civilizations on Mars. But let's take a step back, though, and look at some of the geologic landscapes on Mars during this time. What I want to particularly look at, though, is how the mountains and how the rocks are actually built. This is actually very true for Mars, but not as pointy of mountains either, though. They're usually pretty low to the ground, very rounded out kind of mountains, though. So some beautiful mountains that we actually see on Mars. This is an elevation map, so obviously not true color or anything. It's not beautiful greens and blues on Mars as much as we would like. But this is an elevation map, so the white areas are the tallest points on that map, and then the blues are the lowest points. So this is Flegra Montes. This is around the Elysium volcanic region. So somewhat pointy, but you can see from the white areas, though, is that it's pretty much spread out. It's really not that pointy. It's almost domed shaped going on. You also have Mount Sharp on Mars, where currently one of our rovers is taking beautiful pictures around the area, very beautiful panoramic views of Mount Sharp. But again, not as pointy of mountains going on here. So again, very low, very rounded. But I do want to say the largest of any mountain, not only on Mars, but also in the entire solar system, is Olympus Mons. This is Olympus Mons on Mars. It is the largest shield volcano in the entire solar system, though. So this volcano can pretty much swallow the entire state of Arizona. It is a very, very powerful volcano, but for now, we're pretty much either thinking it's a dead volcano or it's at least very, very dormant, and we do not want to awaken the volcano. So getting into the 1940s, you get into more sensational colorized book covers, and a lot of these illustrations were then revolutionized onto the silver screen. So I wanted to share some of my favorite colorized book covers at the time. So at this point, you have usually damsels in distress. You have creepy monster men coming out of the lakes kind of deal, different kinds of spaceships, maybe the very retro looking weaponry going on, even the different kinds of spacesuits. This is certainly my weirdest book cover I found, which was Life on Jupiter, a short story within the anthology called Fantastic Adventures. So if life were like that actually on Jupiter, it would be very entertaining indeed through all those thick clouds. But let's take a step back as to what was going on in the 1940s. So late 1940s, you have the Department of Defense pursuing rocketry research, though. In the 1950s, specifically 1957, you have Sputnik 1 launching from the Soviet Union. And then 1958, you have Explorer 1 launching from the United States. So from the launching of those satellites and kind of a bit of a panic with people going, oh no, now we're sending satellites, we're sending communications, maybe even spyware up into space. Now on the silver screen, you get into what's called the visitor era of the 1950s. So this was a huge boom in sci-fi cinema at the time, where you have a lot of visitors coming to Earth. So not necessarily going forth and going on adventures to other planets at the time, but more or less having visitors come to us, and whether to spy on us or try to destroy our world, or just something like maybe to even study us. So I'm going to pick a couple films from this list to kind of go through what are some of the planetary adventures that some of these films actually possessed. So first one up is Destination Moon of 1950. Join a weird trip of lunar exploration. So a couple interesting clips from this movie. It was actually a really good film. I do recommend it. But the landscaping was quite interesting. So again, clip of the movie here. You see two major things going on here. You have mountains in the background, which is actually pretty true for its geologic time though going on. So there are actually mountain ranges on the moon, but not very big. But neither are these mountain ranges here in the film either. They're really not that big. They're not grand. They're not pointy or anything though. Same as the mountains on the moon. They're not. They're really grand, but not as pointy either though. So as you can see from the right here, this is one of the Apollo landing sites on the moon. But you could also have a little bit of pointy mountains, though. So this is a fantastic central crater in the Tycho crater on the moon, on the lunar surface. Another weird thing that you probably noticed in that picture, though, are the polygonal cracking going on. So whether the filmmakers wanted to go for more of a dry landscape, a desolate landscape, it's that kind of deal with the polygonal cracks. Not too bad, but it's not all over the surface on the moon either, though. So for aesthetic effect, yeah, not too bad, but in reality, it's really not that far spread. Now, there are cracking in certain craters on the moon, which we call riles. This is actually from extensional cracking of the surface, though. So what happens is that for Komarov crater here, you would have some sort of thermal heat signature of the crater pretty much expanding and contracting and expanding and contracting. Now, rocks are very solid objects, a very solid surface, so it can't just easily be fluid like that. It's going to have to crack under pressure. So we see some of these cracking on a lot of the craters on the moon. So not as extensive. But if you do want to see some polygonal cracking on a much wider surface, you would actually need to go, oh, and that's a close-up of some of the polygonal cracking there on the moon. But you need to go to Mars to see some more widespread thermal contraction going on. So these are the polygonal cracking that we can see on Mars, usually near the polar areas where it's more densely compact with carbon dioxide and water ice features going on. But then you have seasonal thermal interactions going on. So the permafrost rather than the surface would actually expand and contract, and it makes those polygonal features.
Caitlin, how big is that picture that we just saw to give a sense of scale?
The Mars picture here?
Yes.
I'd say about 2 football fields. So pretty up close. This is from the, sorry, my computer was doing something weird. This is from the high-rise camera on board the Mars Reconnaissance Orbiter. All right, onward to Forbidden Planet. This is a favorite film for most cinema lovers of sci-fi. It's kind of a mecca, if you will, that you have to watch this film if you love sci-fi. And very young Leslie Nielsen as well. And then Robbie the Robot. You can't go wrong with Robbie the Robot there. So 1956. Sci-fi. So look at this beautiful landscape of Forbidden Planet, again with the pointy mountains. Now, granted, pointy mountains far away in the background, very beautiful aesthetic going on as well in the landscape. Now, I want to pay particular attention to how pointy these mountains are. Now, most mountains here on Earth, though, can be that pointy, but usually not that terribly high and so clustered together, though, but that's okay. But we usually don't see these kind of mountains on, like, say, Mercury or Venus or Mars or even larger asteroids like Ceres and Vesta. But what is pointy that can be compared are what's called penitents on Earth that you see here. This is in the Chile, Andes area of South America. So you would have these large groupings of ice that have been sublimated in a certain way. where the ice would actually sublimate away into very pointy angles. Now, what's cool though is that these penitentes on Earth usually range from about 6 feet tall to only 10, 11 feet. They're really not that large. But penitentes are much, much larger on Pluto. So this is the bladed terrain. Its official name is called Tartarus dorsa. Um, we also nickname it the snakeskin terrain on Pluto as well. So these very spiky, high up mountains are miles and even kilometers high up in the air, very spiky, pointy mountains. So if you ever want to land on Pluto, do not land there. All right, so back to history reality here for a little bit. Now we're getting into a little bit more of space travel going on. 1961, you have Alan Shepard becoming the first American to fly into space. 1962, a year right after, you have John Glenn orbiting Earth. You have Project Gemini. And then soon to follow in the late 1960s, you start to have the Apollo missions up and running, though. So you have the Apollo 7 orbiting Earth, Apollo 8 orbiting the moon, and finally Apollo 11 landing on the moon. So all of this taking place of not only advancing our rocketry systems, but also our need to go explore. So with that exploration in mind, though, we enter the spacesuit era of the 1960s. So keep in mind, 1960s is also where you get more colorized film as well. So Technicolor has now become a much larger boom. It made its start in 1950s films, but the 1960s is where you start to get really experimental, I should say, with not only the landscaping and the adventures, but also very much the spacesuits, the very bright neon colors and the weird designs and different helmet designs. You start to get a little bit weirder, if you will, with some of the aliens involved with some of these places as well. So I'm going to go through some of these films as well. So first up is First Spaceship on Venus, 1960. So this one was an interesting film. I honestly didn't know this film existed until about a week ago when I was preparing this presentation. Ended up watching it, and it's a film. It's a thing. It's a ride. I will tell you that. So interesting landscaping going on, though. So we have our beautiful view of the Venusian surface, though, but that is really not the case at all. We actually didn't know what the Venusian surface was until much, much later, way after this film was even came available, though. So instead, we have Venus in all of its beautiful clouds. We had no idea what the surface was until the Magellan era of radar systems and radar cameras, and then we finally see at least an elevation map of Venus. So what you see here is, again, the white areas are the highest elevations, and then the dark blues and purples and even black areas are the very low points of Venus, though. So notice, though, is that you have this grand mountain belt, if you will, around the equatorial region there of Venus. And from this elevation map, we were able to see that there was a ton of volcanoes. So I believe we're up to 400 volcanoes and still counting, apparently. All shapes and sizes all over Venus, though. So whether the volcanism is still active is actually still under debate. This movie did have lava, though, so good job for this movie for having Venus to be a volcanic planet. Its lava, however, did look like chocolate syrup from the Willy Wonka film, so very sludgy, very brown. It kept bubbling. Apparently, the lava in this film also kind of had a bit of a mind of its own and would slowly follow the astronauts and to try to kill them, though. So lava everywhere kind of deal, though. But in reality, Venus is very dry, very, very hot. This is an image from the Venera 13 taken in 1982. But before even Venera 13, we had the the Soviet Union had the orbiter of Venera 4, successful orbit around Venus, and then finally in 1969, the Venera 5 lander landed successfully. Granted, communications didn't go so well with Venera 5, but the Venera systems eventually improved, with also Venera 13 here in 1982, taking spectacular panoramic images. It even took images downward onto the lander. And you can see that the rocks are just very flat, very jumbled around kind of deal, but very much molten lava at one point, but dried up now. Another fun part about this film is that a static discharge was in the air, that lightning was starting to be produced all over the place. So this is an interesting thing that the movie had brought about, is Venusian lightning. This is actually still a debatable topic for its time. So for now, we've only found at least maybe some evidence that Venus may have had lightning, or is still going through lightning right now. So I highly recommend this paper by Ralph Lorenz, Lightning Detection on Venus, a critical review. It goes through the process of, okay, if Venus were to have lightning, here are the conditions of how it could be possible for Venus to have lightning. And even you can have lightning from volcanism, which Venus has plenty of. So this film of 1964, Santa Claus Conquers the Martians. If you really want an interesting holiday movie for your relatives, I may or may not recommend this movie, though. It is an interesting film, to say the least. It is quite short, luckily, but nonetheless, was very, very surprised that they did actually have a tiny bit of science relevance to its story. So they actually had the Canals of Mars map, which would have been relevant for the time being of the 1960s. We didn't have a very accurate geologic map of Mars until much, much later. So the Mars globe that you see here, that has some weird dots and a little bit of stripiness to it going on here, this was actually a factual map of Mars, just a little bit outdated though. So let me explain about the Canals of Mars here. So 1877, you have Schiaparelli using an 8.7-inch telescope, and he helped produce the very first full map of Mars. So notice here though is that this map had a lot of lines, a lot of straight lines going on here. And from making of this map, he figured, oh, if all these are straight lines all over the surface of Venus, then there must be canals. There must be boat systems. There must be aqueducts all over Mars. Therefore there must be yachts, kind of deal. Fun fact though, what was actually going on to make those straight lines is that it was his own eyes that were pretty much tricking him into seeing those straight lines. So little experiment here. If you've ever just kind of stared into an eyepiece, or just kind of stare out into a bright window for a long enough time, you start to see little trick of the eye lines, your own eye veins kind of coming into view there. It's pretty much what happened here. So lo and behold, though, that these globes did exist for a time being, until obviously much later, when we had much better reconnaissance orbiters, such as the Mars Global Surveyor of the late 1990s, or early 1990s. You also had the Hubble Space Telescope take beautiful pictures for its time of 1990s as well. So for the time, though, this was actually one of the only factual part of Santa Claus Conquers the Martians. Onward to 1964's Robinson Crusoe on Mars. And this one opened up with a beautiful, brilliant sticker. This film is scientifically authentic. It is only one step ahead of present reality. Let's see about that, shall we? On the fiery planet Mars, if you're going to open up like that, why are you making Mars fiery. The hottest it can get on Mars is a beautiful, balmy 70 degrees Fahrenheit. And then the coldest it can get is about negative 195 degrees Fahrenheit. It could get a little bit warmer than that around the equatorial region, but not to the point of it catching fire at any point in sense of the word there. So fiery Mars, no. Next thing, large crystals. So as a geologist, what you would need to require to get large crystals, and actually you can do this at home too, is you can have grow your own crystal kind of experiment going on, and there's plenty of ingredients that you can Google as well. It's a very fun experiment, also growing salt crystals as well. So large crystals, for it to be this large in this crystalline, not only are you going to have some very constant temperature going on, but also a very strong pressure as well to constantly build up that crystal system going on. So neither of which Mars actually has. Mars has a very weak pressure. It's in the millibar, where our Earth pressure is at 1 bar pressure. And then temperature, it's still not fiery. So no, sorry, no to large crystals. However, there are essentially beautiful fields of minerals on Mars. So if you ever want to really dig for rocks and minerals and go rock hunting on Mars, I highly recommend around the Valles Marineris area. There are opal fields near Valles Marineris. Now, opal is an amorphous mineral. So opal usually would have had to have some sort of water compound in its chemical structure. So finding opal near Valles Marineris was kind of a thumbs up clue, if you will, as to whether there would have been past water on Mars or not. So opal, very pretty on Mars. However, it's very unlikely that it's gem quality by any means. So certainly not the type that you would see in jewelry stores or on Etsy or anything like that. They found water on Mars. Who knew? This film found water on Mars before anybody else. Good job. So there is water on Mars, just usually not liquid at the surface like this, to the point where you don't want to drink, by the way. You really do not want to drink Martian water by any means. So definitely not liquid on the surface. However, there are plenty of clues to water on Mars. So we have beautiful gully systems. These are zoom in pictures, usually only 3 kilometers wide are these pictures though. So very beautiful gully systems. You have what's called RSLs, or recurring slope lineae. So these are still very mysterious looking slope streaks that you would see within craters or even with gullies as well. But there's also brine water on Mars, so incredibly salty water on Mars, and we could actually find these through radar echoes. So the largest liquid pond that we've ever found, and very recently too, only within the past 2 years, it was in the southern pole of Mars. Then this film also had adventures to the polar ice cap. So you had either a very glowing, mountainous blue color of an ice cap, or what's almost drawn as like early Disney animation. This is not a Disney film, but the animation of the polar ice cap there looks a little Disney. But in reality, the northern pole, you would have a lot of layered ice. So you can see this by a lot of the dark streaks going on there. So all that dark streakiness going on there is frozen nitrogen that is being slowly sublimated out of the ice. And that sublimation can sometimes cause avalanches. So all that streak marks and all the ice just kind of sloughing off in seasonal cycles. Now that's the North Pole, but the South Pole of Mars is where the fun mystery begins, because you have Swiss cheese. We have no idea how in the world this stuff is formed. We have some pretty good ideas, but why it is speckled like this? Now, keep in mind, these are actually pits. It does take a while for the untrained eye to realize that these are pits and not rather globs that are popping out of the screen. Instead, these blobs are actually going into the screen. So these are just giant squiggly pits. For geologists, though, it's no fun to call them pits, but we don't know what else to call them, so we're calling it Swiss cheese as kind of a fun little nickname for this kind of terrain. But it is all over the South Pole, and the fun part is that this type of terrain is only found in the South Pole of Mars. It's not found anywhere else on Mars. It's not even found anywhere else on the solar system. It just happens to be on the South Pole of Mars, and still a mystery to us Mars geologists.
How big would the average of those objects or whatever be?
Small. I'd say at least 5 kilometers or smaller.
Mhm.
To a geologist, 5 kilometers is small. Yeah, and some of them could also, you can see also in the middle here that some of the globs kind of merge into each other, and they can create a much larger pit over time. There are some images that show some of these pits actually shrinking and growing and shrinking and growing during different seasons. But why that is and why the different shapes, the more south you go and at a different longitude, some of these pits actually become more like cheese doodle type kind of deal. I'm going to go with all the cheese things here going on. But yeah, you could have smaller pitting going on. You could have the cheese doodle linear pits at some longitudes.
Now, isn't that
It's a very weird system.
You describe them as pits, but to my eye, they look like raised surfaces compared to
Yes.
fascinating.
Yes. It does take a long time for the eyes to adjust when you realize where the sun angle is. Then it's like, oh, that's what's going on. All these are actually into the image, not popping out.
Wow.
It's very confusing, and even I'm having a hard time realizing that these are pits and not raised bumps.
Mhm. By the way, while we're on this slide, someone named Austin has asked if there's what's under these pits. Is there any way to assess what that might be?
Possibly. So we haven't done terribly much radar imaging around the Swiss cheese. What we can find, though, is that there's a lot of carbon dioxide ice at this particular South Pole. Now, does the carbon dioxide mixed with sublimation and then the sublimation angle of the sun kind of affect the growth pattern of these pits? Possibly. But you could also get sublimation in the North Pole too. So it's still a huge difference between this, which looks much more solid ground, versus this. And so why the immense difference? You have methane ice on both poles, which is fine, but carbon dioxide might be the key here. Water. There might be underground water systems with the South Pole versus North Pole, and that could be causing some sort of weird sublimation difference going on too. There are very few people who are looking into this for now, though. But it's still an ongoing mystery, to be sure.
Thank you.
Yeah. All right, onward to John Carradine as the wizard in The Wizard of Mars. Now, if that's not a play on words, I don't know what is, but thank you, 1965, The Wizard of Mars. So this one was a very fun movie to watch. So one of I will mention at least just one scene, though, is that they are on like a little dinghy going through a cave system on Mars. The fun part is that there are actually cave systems on Mars. Kinda. Maybe not necessarily to take a boat and you can float through the cave systems to safety to get away from present danger, but it is a possibility to use cave systems on Mars as a way to protect astronauts. So we're actually looking into this on the moon as well. There are small cave systems across the moon And what you would do is that you would find a safe opening. You would find a thermally stable, also a rock stable cave system on the moon and Mars. And what you would do is that you would pretty much set camp into that cave system. So why caves, though, is because you wouldn't get as much radiation on the surface. So here's a couple small what's called skylights on Mars. So these are in two completely different areas on Mars, though, but these would essentially be the entrances to a much larger cave system that's underneath the ground. Whether these are stable cave systems, that's actually still being looked into especially for future astronaut ambitions. But the size of these craters are probably about a football field size. So in terms of geologic pits, that's pretty average, pretty small on the smaller scale. So not too bad. Moon 02. This one I highly recommend. This one was a fantastic film to watch. This was 1969, so we're getting into the huge boom of the Apollo 11 landing on the moon. So now all of the lunar type films are really starting to be on the forefront, though. But Moon 02 had an interesting spin to it as well. This was actually the very first film to feature mining on a completely different surface. And I'll show you that here in a bit, though. So of its title screen, though, I do want to mention it is set in 2028. Well, okay, sure. Why not? 2028, okie dokie. Artemis is still maybe set for 2024. We're not entirely sure. Just on, it's not exactly set in stone with Artemis, though. But hey, who knows? Can we make it all the way to Moon 02? Probably not to the standard that Moon 02 actually shows in the film, but do we hope to at least be back on the moon at some point by 2028? I sure hope so. One thing I do want to look at, though, is this title screen, though, with all the crater systems. We're finally getting images back from the Apollo 11 mission, though. So yes, beautiful craters, beautiful title screen here. It actually shows different kinds of crater systems here. It almost looks like some of the craters have what's called a central peak, where you have a crater and just a little mountain in the central part of the crater. So here's our beautiful mining on the moon operations, though. I want to see two completely different mining operations here, though. You have the pointy tent looking structure going on there, the central building, the headquarters, and then you have the little domes. More likely, we're not going to have the pointy, grand structures kind of deal. They'll be mainly because the pointy structures are probably more likely to get hit by some sort of, asteroid, meteor that happens quite often in space, much more than we think we know. So more than likely, we're going to go with the dome system going on here. Another thing, too, is that they had these pretty large tractor systems going on, very similar to bulldozers here on Earth, though. But this is a huge no-no for mining on the moon. At least if we were to mine on the moon or even mine on asteroids, we're not going to just send a bulldozer to the moon. No, it's a huge no-no, and geologists would be mad forever and ever if you were to do this. Now, why don't we send a bulldozer to the moon is because we still need to learn about a lot of these rocks. Some of these rocks are actually very, very toxic to humans. So yes, there is water on the moon, especially from the recent SOFIA, using the SOFIA telescope very, very recently. Go check out that paper. It's a fantastic study by Dr. Casey Hannibal of Goddard. So fantastic work by them. But in this case, though, water is not liquid on the moon, not in this capacity to just have a bulldozer. But also there are signatures of very toxic chemicals on the moon as well. So you don't want to just dig up these rocks and go, hey, we're mining. No, we really need to be careful as to where these certain dangerous chemicals are around the moon. We're still doing mapping efforts all across the moon for that purpose of making sure we can have our astronauts go to that certain spot safely. So 1970s, unfortunately, you start to get into the government era of cinema. So in this case, though, you have rogues going on in terms of cinema. So you would have secret alien bases. You would have the aliens being hunted down. You have astronauts being hunted down. That one was with Capricorn 1. Interesting twist in the end. I'm not going to give that one away. Moonraker. Wonderful James Bond film, if you're really into that. Alien, especially with the crew being expendable. So this is kind of where you kind of get into a little bit of a paranoia, if you will. But in any case, though, the one thing I could take away with all this, though, is don't touch the alien eggs. If you're really close in contact with something that's mysterious, we geologists love to lick rocks, but we know our limits, or at least I hope that hopefully speaking for all planetary geologists, though, we know our limits. We know what not to lick, hopefully. So now getting into a little bit of modern cinema that I wanted to touch base on. I'm going to just kind of breeze through these 4 films, starting off with Rocketman of 1997. Rocketman is actually a very fun Disney film for its time. Rocketman, you have pretty much the first mission to Mars. You have 3 astronauts and a chimpanzee astronaut as well. But a huge dust storm comes along and kind of pretty much causes chaos to the mission. So the dust storm that they portray in this movie, actually works out really well. It pretty much just darkens the entire sky. It's incredibly dusty. Everything gets coated in the orange rustiness of Mars. It actually works out pretty well. But having such strong gale force winds to disrupt machinery and practically knocking over the astronauts in such gale force winds, no. So what I mean, though, by dust storms on Mars, though, it can happen. There are dust storms that happen almost on a not so seasonal cycle, but it can completely envelop the entire planet into darkness for even several months at a time, and then eventually clear up. Armageddon. Armageddon is an interesting movie, to say the least. I doubt that the very beginning of the movie would ever happen, because the very beginning of the movie, you pretty much have all these government officials that go, "Oh no, an asteroid is gonna crash into Earth. Oh my goodness." We would know very much ahead of time if something like that were gonna happen. So we have the technology, we have certain programs within NASA, especially to track down certain dangerous potential asteroids that can come in real close to Earth. But we would know very much ahead of time and not on the clock. Oh, we only have like 24 hours to destroy this asteroid and everything. Like, no. So I gotta love the huge machinery that they try to get involved with trying to blow up the asteroid, though. But nope, nope. Another fun landscape that they have for this particular asteroid is that they have very large and pointy. Now, it's a very interesting aesthetic that they have here. It kind of makes it very ominous that it's not just this flat piece of rock or anything, though, that it's very dangerous of how you're going to blow it up and watch your step and everything. And that's fine, except most asteroids are just very beautiful rubble piles. So not necessarily pointy. There can be mountains, especially on the more larger asteroids like Vesta and Ceres, though. But this particular image taken by the OSIRIS-REx mission not too long ago, yep, not very many very large, pointy, scary rocks anywhere. One thing I do want to take away with this film is that NASA actually still uses Armageddon as more of a fun training exercise for astronauts or people who train astronauts as well. And so what they do, though, is that they use this film as not necessarily a training exercise per se, but you watch the film and you write down all the good versus bad protocols through the film. And this particular scene here with Steve Buscemi here is he's going a little crazy in space going on, so they pretty much have to duct tape him down to make him calm down, and that is actually part of the protocol. If you were to kind of go a little crazy in space, is that we actually will use duct tape. Maybe not to this extent of across the body and everything though, but you would pretty much duct tape the wrists and ankles, and then you would try to secure yourself against usually the space station wall or just some sort of surface to calm down. Next up, we have the 2013 Europa Report. So this is quite a long film. So if you're really not one for very long films, it's okay to pause in the middle and give yourself a break. It is kind of a long film, but beautiful nonetheless. They did a fantastic job with bringing about some of the beautiful images going on. So at the time, Cassini would have already been at or just getting the Saturn at the time though, but beautiful images. So this is taken from the film at Europa. Oh, I'm sorry, Cassini was at Saturn. Wrong planet. Never mind. Anyways, so again, we still got beautiful images from Voyager and then even the Galileo mission in the 1990s at the time. So those would have been the instruments at Jupiter. But comparison-wise, they did a fantastic job bringing about the weird scratch-marked looking surface of Europa in that opening scene there. You also have kind of a zoom in on some of the larger, what's called chaos terrains on Europa. And I'm actually really happy that this film showed how weird the surface is. Now, if you were to look at this picture and go, yeah, that looks weird, that shouldn't be on the moon. Well, Europa is full of surprises. Europa has one of the strangest surfaces of a moon in the solar system. So a lot of this is called chaos terrain because we geologists are like, yep, we don't want to touch it. That's so much work to do. But lo and behold, we call it chaos terrain for a reason. It's a fantastic, beautiful moon as far as geologic regions go. And then finally, 2015, we have The Martian featuring Matt Damon based off of the book, The Martian. I highly recommend the book. If you've already seen the movie, that's fine, but I highly, highly, highly recommend the book because it goes a little bit more in depth into the technical and engineering side than the movie. So real quick though, that dust storm, it's very much like Rocketman, the Rocketman movie. This movie also opens up with a horrendous lightning and full force, gale force winds, hurricane style dust storm of Mars though. So why I'm saying no to how the sheer strength of these dust storms on Mars is because the wind pressure would not actually be that great on Mars compared to Earth. Now think of it this way, the scale of that dust storm would very much be true. The walls of dust coming in, it's going to blot out the sun, it's going to be horrendous for any kind of solar power battery going on. That's how we lost our recent rover, and unfortunately Curiosity's doing fine because it doesn't have solar power. But poor Spirit and Opportunity got buried by sand, and there goes their solar power. But in this case, though, at the beginning of this movie, you would have the storm pretty much the reason why Matt Damon is stranded on Mars, to the point of picking up shrapnel and pretty much like stabbing Matt Damon through the spacesuit and penetrating skin. That's a lot of sheer force of wind, which can very much happen here on Earth with tornadoes and gale force hurricanes and typhoons. But on Mars, not so much because of that air pressure. So about comparison here, about 100-mile-per-hour winds here on Earth is actually only 11 miles per hour wind on Mars. So very light breeze, if you will. But then again, if we were to have that very light breeze on Mars, you wouldn't get the Martian. You would just destroy the whole plot. So I guess we would have to settle with gale force dust storms on Mars. Now, a lot of the imagery with this movie, they did actually consult a lot of high-rise camera people from the Mars Reconnaissance Orbiter, and it actually made mentions to a lot of these reconnaissance orbiters in the book and in the movie. And one of the major features of the film is getting to Schiaparelli Crater, and they did a beautiful job with that. Now, the thing about it is that for the movie, they needed to make it kind of easy for your main character to reach the crater. But in reality, Schiaparelli Crater has somewhat large ridges of its rim that it would have taken Matt Damon just probably a little bit longer to venture up and then into the very numerous dune fields within that crater. So, give and take. But through all the cinema that we have gone on our adventure today, we certainly have a lot of our own alien surfaces across our own solar system. There are still plenty of weird geology in our solar system that we ourselves still need to explore. And whether cinema would take that later into whatever future cinema holds. But with our own exploration, either through literature or even through research, there are still very, very beautiful and weird alien worlds that we still need to explore and certainly go back to. A lot of these moons that you see here are around Saturn, so Saturn certainly has the weirdest collection of moons. But also Jupiter has some weird moons as well. You have Io kind of in the middle there, a very yellow sulfuric moon as well. But again, how these moons are made, why certain moons have atmospheres and active volcanoes, and why that one moon looks like a squishy sponge, or that one moon off to the left looks like a ravioli. We're still trying to figure that out. We're still trying to explore our own solar system. So cinema for the 1950s, 60s, and 70s did a fantastic job trying to explore how they can create certain landscapes without ever really seeing the landscapes themselves, especially of the 1950s or early 60s when we haven't even been to the moon yet. So I will leave it at that, and I will be happy to answer any questions that anybody has. Thank you.
Thank you. I do have questions here from our folks. Before I get to that, though, with this slide, I've never seen that object at the upper left before. Would you tell us about that?
Can you see my cursor?
Yes.
Awesome. Okay. Yes. So this object here.
Yes.
Yes. Yes. So this is Pan. There's also another moon called Atlas that looks very similar. So we call these the ravioli moons, Atlas and Pan. So Atlas and Pan, you have kind of a weird history. This is within the Saturn system going on. So these are incredibly tiny moons. They're only a couple miles large, though, so barely reaching kilometer size going on. So the weird part, though, is that you have this weird tutu like of rock. So what we're probably thinking here is that these moons would have been at such high velocity coming toward each other. And with that high velocity, you have a lot of heat. And with that heat in those two rocks, you would have pretty much melted the rock as they squished together, and it forms that little rock tutu around. So that's the main theory. There's a bunch of other possible theories going on as well, though, but that's pretty much the favored theory as to how these little moons would have formed.
How interesting that it looks kind of like a ringed world, and they're orbiting the ringed planet, which is, of course, a very different type of ring that Saturn has with boulders and right down to, dust grains. But this is a solid,
A very solid, thick ring.
physically connected. Interesting.
Yeah.
Let me get to the questions from our guests here today. I did want to put in a quick plug for the Science and Entertainment Exchange. Some of our members of NCAS are involved with the Science and Entertainment Exchange for movies like The Martian and other science fiction movies, where people in Hollywood can get in touch with astronomers or other scientists and ask them, hey, I want to have something about Mars in my movie, and they can try to make it as realistic as possible by consulting with a scientist. All right, I see here that you were going over the early history from the 20th century of different books and movies, and we have, let's see, this was someone named Claude joining us from Auburn, Washington. He says, let's not forget John Carter of Mars, the Edgar Rice Burroughs series of books on Barsoom. That was the name they had, the Martian natives had for Mars. And I'll throw in here, we just had a birthday anniversary of Carl Sagan, the great skeptic and astronomer. And he was inspired as a child by those John Carter novels, and, growing up in Brooklyn and reading about Mars far away. And I'll throw in this last thing about John Carter from Virginia. So our national capital area, he would be on the slope of a river, a bank of a river, and he'd just think himself to Mars to get into the action, if I remember correctly. Let's see. Our member Tom from Silver Spring, who's an astronomer, by the way, at Goddard. I know him, and he's on our board of directors. He brought up an interesting television series. It was a syndicated program that ran in the 1959-60 season called Men into Space. And it's actually kind of a prosaic, relatively level-headed program. I've seen a few episodes. And it had space stations, moon bases, trips to Mars. But as Tom pointed out, there was even a finding of ice on the moon. So that folks who haven't, I believe there are episodes. I've certainly seen some. I don't know if the entire series is available online, but I've enjoyed the episodes I've seen. I don't know if they're all there.
Oh, that's so interesting. I've only seen just a couple episodes, so I must have missed that particular portion though. But that's highly interesting then to already kind of predict like, oh, ice on the moon. It's very interesting.
Yeah. Let's see. You mentioned about the solar-powered rovers on Mars that died as a result of these planet-wide Martian dust storms, and fortunately we have the radiothermic generators on Curiosity, and I think other missions is the one that's going there now. I don't remember offhand if Mars 2020 is also using a radioactive power source.
Oh yeah, absolutely.
Excellent. Okay, I have a question of my own here. There's an infamous movie from, I think, 1968 called The Green Slime, and it's not good. It's entertaining, but I would note that at the beginning of the movie, the action is on an asteroid, a real asteroid named 8 Flora. So it's the asteroid Flora, and it was the 8th one discovered. And they even have a throwaway line, why is this main belt asteroid, between Mars and Jupiter, on a collision course for Earth? So it isn't explained, but at least they did mention that, we don't know why this asteroid is coming towards us, but somebody must have talked to them and given them a real asteroid name and so on.
Oh, that's so fascinating. Okay, I'm gonna have to watch
It
Green
is
Flame. That sounds
online.
like something out of Mystery Science Theater.
But
That sounds like something that they would watch.
it's absolutely right for levity. One of our participants here raised the question of perchlorates. I'm not sure if I'm pronouncing that
Oh,
correctly, on
yeah.
Mars. So Austin has asked about that and the toxicity and other issues, other potential issues of that on Mars for astronauts.
Yes. So that goes back into certainly Mars exploration. Kind of ties back into why we shouldn't just bring a bulldozer to the moon just to dig up rocks. We certainly should not do that to Mars as well. So perchlorates, you would have very dangerous salts, essentially, though, going on. So you would have the briny water that we would finally find on Mars, certainly not liquid by any means. But when that liquid uh, ponds under the within the surface dry up, usually due to seasonal um, biseasonal cycles, what's left over is the residue, or rather the salt, and you would have the perchlorates. And that those perchlorates, though, they can have pretty dangerous chemicals, very toxic to humans, though. So don't lick the salt on Mars by any means either.
Now,
But then that goes back into an astrobiological means of exploring Mars. So you don't want to just find the water and poke the water or anything. There could still very much be bacteria in that water that we're not aware of that could potentially thrive on those perchlorates. But you don't want to automatically have your astronauts in danger and go the water everywhere, but not a drop to drink kind of scenario. You don't want that to happen.
one of our participants here points out, even if Hollywood doesn't get the details right in these films, and some of them probably knew better as we learn more about these planets, at the very least they inspire public interest in space exploration, which is a factor in political support for NASA and I assume for other space organizations, the European Space Agency and so on around the world. So even if they don't get the details right, there's dramatic license or whatever.
Absolutely. Yeah.
Yeah, let's see. Tom from Silver Spring also pointed out that recently there was a showing at the American Film Institute in Silver Spring of a 1920s German science documentary called Our Heavenly Bodies. It's a silent
Oh,
film where you travel to the planets of the solar system, sort of like Cosmos did. I wasn't aware of that. Maybe you can learn more about that. By the way, you'd mentioned different, the scientific paper about lightning on Venus and so on. If it's all
mhm.
right after this talk, I guess we'll post links to those papers down in the comments section so that people can read more
Mhm.
about these after the talk. By the way, Tom is red hot here. He said the Men into Space episode he was talking about that has ice on the moon is called Caves of the Moon. So maybe we can find that. I'll link to that
Yeah.
too if I can find it online. Um, the latest question is there any greater concern than usual that the change in administration will affect NASA projects? I don't know if you're into the politics of NASA. It may be so early to assess, we don't even know who the NASA administrator will be, except that the current one has decided not to continue under a Biden administration. Um,
True. I personally think it's a little too early.
yep, I think so.
Uh, but but discussions are certainly ongoing. Internal discussions are still ongoing.
Yeah.
But whatever the decision, though, we are still very excited about what the administration will bring.
Mhm. Um, Obviously, recently we had the OSIRIS-REx visit to the asteroid Bennu, and one of our participants apparently was part of that mapping project. And the surprise of how rocky the surface was, making it so difficult to grab the sample that they wanted safely. Why was it so rocky? Do you know why it was such a surprise when we actually saw what the surface of that asteroid looked like?
Okay, so as a geologist, it was rather a happy surprise. Granted, what happened is that we grabbed so much sample because of its rubbleness that the sample container couldn't close right away. So it took a while. Unfortunately, particles had to leave the container system for the lid to officially shut and vacuum seal correctly. But as a geologist, that is actually very exciting because now that's giving us a whole new look at surfaces of asteroids, and also now just how, don't want to say unique because that sounds very cliched, but rather how varied asteroids can be. A lot of people usually think of asteroids as being very like Ceres and Vesta, very grand, smooth, somewhat smooth terrain, ridges and mountains and beautiful craters and some salt on those asteroids. But then you have Bennu, this grand shaped rubble pile that now is very soft, very, very soft rocks, but yet the rocks are pointy and like our guest said, very dangerous to even pick a spot directly. So mapping efforts, I'm sure, would have been very fun, but kind of nightmarish, I'm sure, as well. But for geologists means seeing how light and fluffy that material would have been now gives us a whole new breadth of questions, more questions now of, okay, how grand of an asteroid this is with a little tiny spiky rocks held together in space in the asteroid belt with very few craters. So if you were to impact that surface, how would the rocks behave? Or how would the ejecta from that impact happen? Can craters even be created on such a surface, or is it squishy enough to pretty much be like a shock absorber? So all those questions have definitely been growing since OSIRIS-REx, though. So so from that, why aren't all asteroids spiky little rocks of chaos? Why are certain asteroids very smooth, or like the like Itokawa, a very nice smooth asteroid, very small, but certainly does not look like spiky little rubble pile that Bennu is. So something to explore.
My understanding is on the surface of Bennu were some rocks from Vesta, the main belt asteroid, and so tantalizing that our spacecraft was in the vicinity, but apparently there wasn't a capability to target one of those rocks and try to get a sample essentially from Vesta that was riding along on Bennu. Yeah, I'll throw in a plug here for my colleague Dave Lorenz at Goddard Space Flight Center. He was the campaign lead engineer for performing the science sampling from the surface of that asteroid. Hey, I wanted to ask you, you were mentioning earlier about lunar dust. Are there, to your knowledge, any Hollywood or other movies around the world that dealt with the problems posed by lunar dust in terms of potential, lung problems if you inhale it, or the problems of machinery and so on? Off the top of my head, I'm not aware of that, but that's a real thing, isn't it?
It is very much a real thing, but if anything, it's a more recent thing. So we did know that the dust was certainly dusty from even the Apollo 11 landing, and they would just constantly kick up dust, even though the lunar surface is pretty much hard as concrete kind of deal. But yeah, that dust very much poses a threat to astronauts, and even the dust on Mars certainly poses a threat to astronauts as well. So yeah, the dust by all means is very much a problem. As far as cinematic goes, I can't think of a thing. The only film I could think of that had lunar rocks being any kind of trouble is the cult classic Apollo 18. So if you're really into kind of a horror film, sci-fi, but still want a good laugh, watch Apollo 18.
Yes. Yeah, I had a question going back to your earlier part involving the Flash Gordon vistas, beautiful stuff. Forbidden Planet, that was a planet in orbit around Altair, a star not terribly far from the solar system on a stellar scale, something like 15 light years away or 17, somewhere in that range. But I wondered, there's so much data now about the topography of the moon and Mars with laser altimeters and so on. And I'm wondering, has anybody discovered the most beautiful vista that we haven't seen yet, like the landers that we've put down, the astronauts we've put down on the moon are in relatively safe areas, right?
Mm-hmm.
And, so there could be relatively hazardous areas to put a camera and look at a beautiful, think of an Ansel Adams on Mars or the moon. Is there some unwitnessed but hidden in the topography data? Hey, if you put a camera at this location looking at particular mountain on the moon or Mars, your jaw will drop. It would be a computer simulation using the topography data. Are you familiar with whether anyone has sort of explored the surface from that data set?
Oh, certainly. There are quite a few that I follow on Twitter actually that do that very thing, where they would take elevation maps mixed with high-rise images and then try to create beautiful panoramics and beautiful images as specifically for the Martian surface, though. So I haven't seen that particularly done with the lunar surface, or at least not to my knowledge.
Mm-hmm.
But that particular question of what would be the beautiful landscape, that's really up to everybody is a different geologist
Sure.
in their own mind. So like my view would certainly be different than a different geologist. So it kind of reminds me of how we decided the landing site for the Mars 2020 rover. You had like Northeast Syrtis, you had Jezero Crater, and then you had a third site that I can't think of the name of at the moment, though. But you had all these geologists pretty much, and chemists and astrobiologists and atmosphere scientists, all these planetary scientists going at it of like, we should pick this spot because blank, we should pick this spot because blank, and so on and so forth.
Mm-hmm.
As you know, I personally wanted to go to Northeast Syrtis because you had almost a volcanic interaction going on there. But Jezero Crater is still absolutely gorgeous with that delta fan that Mars 2020 is going to be really close by. So that view of that delta fan is going to be gorgeous. But me personally, I think a really neat angle of the steep ridge off of Olympus Mons, and then you have kind of like the rest of the landscape of Mars in the background. I think that would be a beautiful landscape image to be sure. But that's just me. I like volcanoes.
Mm-hmm. Yeah, as you know, about a month ago, Mars was closest to Earth for quite a while. Probably, I don't know, something like a dozen years or something is the next closest approach. And I had the opportunity to look through a telescope at Mars and actually see the general area where Mars 2020 is supposed to set down. It was relatively good seeing that night. And so anyway, folks, if you go outside in the early evening, you'll see the brightest thing over in the eastern sky is Mars. It's still pretty bright, and to enjoy that, you'll notice the reddish color there. Let's see. Do we have any other questions? Oh, I wanted to ask you about these spiders, space spiders. Can we go back to that slide?
Yes.
I was kind of shocked.
Whee! Funny enough, there are actually spiders on Mars, but not critters, not critter spiders. But it's another endearing term that we gave to a certain geologic event. But yeah, there we go, space spiders.
Fascinating. So
yes.
Let's see, this is on the moon that these spiders exist? Or
not necessarily. They were brought, I believe that they were brought from the, oh yeah, I guess it would have been on the moon. They were brought from the people of the sun as kind of a like a war weapon.
Wow. And do we know
a
whether
distraction.
it's Lucian? Am I pronouncing that correctly? The writer here. Was this presented as fiction, or did he or she actually believe that this was might be what's happening on these other worlds, on the moon, battling sun people and so on?
I believe at the time, well, I mean, I'm not entirely sure when the first mention of what was considered fiction at the time, but my guess would be they wanted to write an epic, which would have been prevalent to Syrian and Greek writers at the time, what they would consider their own adventures. So not as, kind of getting into Odyssey or Odysseus and Iliad type epics going on. Except in this case, instead of Greek gods and goddesses, you have moon people and sun people battling it out for the universe kind of deal. And it's like, oh, okay, that is certainly new.
You had mentioned this nickname for something on Mars involving spider, using that name. What is that? We've just gotten a question about that.
Yes. So the closest image I have of that is this. It's the North Pole of Mars again. We go through Venus. Hello, Venus. Hello, Mars. Sorry, Mars. Water Mars. There we go. Okay. So I had mentioned these the black streaks going on here. So slightly lower latitudes than the North Pole, but still highland latitudes though. Wherever there's still bulk of ice in the northern latitudes going on, you would have these black spots, but all over the place. And this is usually found in the spring season. So what's going on here is that you would have nitrogen and carbon dioxide as vapors trapped in the ice when it becomes fall into winter. And then winter traps all that ice. When spring comes around on Mars, you start to get slightly warmer temperatures and that ice starts to sublimate. But we think sublimation, like it's just automatically melting the ice. But sublimation on Mars kind of works a little bit differently, where the sun slowly eats away at the ice in holes kind of deal. So again, back to that Swiss cheese, but not a grand scale like it does on the South Pole. But North Pole, it pinpricks the ice, if you will. And that pinprick, as soon as the vapors that are trapped within the ice, that carbon dioxide and nitrogen, it mixes and it puffs up as soon as it's free to escape. And it causes a blackness of the ice. And what it does is those little poof marks. It makes it look like a spider. And so in the spring, it's the oddest thing. When you're looking through images, you immediately know when it's spring, because you could have fields, like football fields upon football fields of these tiny little black poofs all over the place, and it just looks like Mars is just taken over by spiders.
Hmm.
So that's the endearing term that we use, is that we call these Martian spiders.
Mhm. One of our participants here has brought up the asteroid Ceres. From a skeptic's perspective, when we were first seeing images of the Ceres surface and these really strange bright spots.
Oh,
And
yeah.
now, of course, we have a better understanding, I assume, and what those strange bright spots on the surface are.
In a sense, we have a better idea of chemically what they are,
Mhm.
but how it's there, we found multiple spots now. We just happen to, the news tends to go toward the biggest and brightest one, but in reality, there's like 5 or 6 of these bright spots all over a series.
Mhm.
But why only those particular spots? Why are they still bright? Usually, in terms of ice, anything that's very bright like that means it's very fresh. So, in terms of geology, what's considered fresh then on an asteroid? And so, what we're thinking for Ceres, though, is that Ceres may have its own asteroid form of cryovolcanism, where you would have not fiery Mars, not fiery Venus, or even Io, very sulfuric and active and fiery kind of deal, but rather ice and salt, usually with ammonia, the same kind of ammonia that we have in our cleaning products here on Earth.
Hmm.
It really not that exotic or anything, but usually you mix ammonia salts and a little bit of water ice, mix it all together, you pretty much have your cryovolcano on an asteroid. And you could also get the same kind of mixture on all the way out at Pluto, even. A little bit of different chemistry out at Pluto, though. You have a little bit more methane involved. But back to Ceres, you would have ammonia salts and water ice kind of do some sort of gloopy chemistry on the subsurface. But then how did it get there?
Mhm.
And why? And why those certain spots? How would it have been able to, kind of squish onto the surface like that and still be so bright? Those are the questions that we're still trying to figure out as far as Ceres goes.
Yeah, I guess the Jupiter and Saturn moons are affected by tidal forces from those, giant
Mhm.
planets. But what are the forces affecting the interior of Ceres that would cause these materials to come out?
Exactly, exactly. And we're still not entirely sure what the interior of Ceres even is. Did Ceres have some sort of active core at one point? Did Ceres even have a core? Was Ceres its own core of a protoplanet, and then it just pretty much got stripped away of a mantle and a crust? We're thinking that may have happened with Vesta for sure, but did Ceres end up with the same fate? So close. You know, who knows?
Hmm. All right, looks like maybe we're wrapping up here. I want to thank you again, Dr. Ahrens, for a great talk and bringing the Hollywood art with the science of today. It's a beautiful mixture of inspiration and knowledge. I do want to point out that we have our next speaker on December 12th. Please join us then, Saturday, December 12th at 1:30 p.m. Eastern. We're going to have Bob Nygaard. He's a private investigator. He helps clients who have been ripped off by so-called fortune tellers, psychics, etc. That's December 12th at 1:30 p.m. Eastern Time. Today's program was produced by JD Mack. Thanks, JD. And stay safe, everyone. Join us next time. Bye-bye.